and Linda will open up the time at the end for a period of question and answers. So again, Linda, thank you for joining us, and please go ahead and start your machine safety webinar. Thank you.
Thank you, Pete. Good afternoon, everyone. As Pete mentioned, my name is Linda Caron. I am certified with TUV in Germany on machine safety, and I look after the global markets for Parker Hannifin. So I am responsible for the US, Canada, the Asian markets, as well as Europe. And I'm happy to join you today to share some information on machine safety and bringing machinery to a safe state. As Pete asked, if you could please hold your questions until the end. I have 18 slides to get through, and I'd like to get the content covered, and then we'll open the floor and answer any questions you may have. So the 18 slides are broken down as follows on the agenda: why we're hosting this session, the facts that we have, what we know today about safety in industry will be covered in 5 slides. And then we're going to do 5 slides on what the standards say, the regulatory validation on making machinery safe. And then the last 6 slides are the next steps and how we can help you with your respective machine safety requirements or concerns. And then we'll open up the floor, and hopefully we can get all the questions answered today. So first of all, safety is ingrained in our culture, and that was one commonality between the RG group and Parker. To be brave enough to make a difference, to care for others, we have the people and the experience and the products to drive positive change. We want to be a trusted advisor on a really confusing topic in the marketplace. There's lots of codes and standards and different organizations you can go to for information, and it almost becomes overwhelming. So we all know who OSHA is. OSHA kind of regulate and police safety in industry, and every year 6,200 people roughly will die as a result of industrial-related accidents. That's way too many people. That's 16 people a day. And 10% of those individuals will die from the failure to control hazardous energy in a machine. This is something so simple that we can all work together and fix. These accidents should not be happening. We can really make a difference in this area. OSHA cannot do this themselves. They have a huge budget decrease, and it would take them 159 years to inspect all of the plants in the U.S. So we need to work together to make industry better. What we do know is that OSHA writes a lot of citations because of machinery-related injury or death. And the ones I've highlighted in red are the ones where I feel we can really make a difference. Things like machine guarding, and really the isolation and energy in a machine has to be dealt with. To bring a machine to a safe state, we can't have trapped residual energy in a machine. So, where do our customers go for information? A U.S. magazine did a survey, this is back from 2015, and they realized that consumers and people are very confused about where to go. They're going to ANSI and OSHA and EN and IEC, and some of them even come to us, the component manufacturers, to Parker Hannifin for help, and companies like RG Group for support and assistance with systems. So how does this all tie together? How does this work? ISO writes the standards. They were founded back in like 1947. They've been around for a long time. They're predominantly thought of as being European, but today ISO looks after 21,000 different standards, and they have 163 member companies worldwide. So ISO is probably the largest standards organization. Then we have ANSI, the American National Standards Institute, and ANSI oversees the development and adoption of standards, many of these standards coming from ISO, for the U.S. market. And then there's OSHA. the police who set and enforce the standards by adoption, applicable law. And for things they generally deem unsafe, they have something known as the General Duties Clause. So that's an interesting one, and we can talk about that a little bit more as we go. So what does ISO say? The regulatory validation from ISO, and these regulations almost all in some way define isolation and energy dissipation as being necessary. So here is ISO 14118, section 3.3, and I won't read it all to you, but the gist of it is that it's an international standard about safety of machinery and prevention of unexpected startup, and it states in the gray text, dissipating any stored energy which may give rise to a hazard. It could be pressurized fluid, it could be pneumatics, energy stored in mechanical components. And then, ISO has obviously 13849-1 is another standard, and it very clearly states that trapped residual energy must be eliminated to prevent unexpected startup. And these two standards are predominantly in Europe. However, in the United States, ANSI has adopted these standards under what they call ISO 12100, and Section B11 states that it is applicable law and enforceable by OSHA that measures must be taken to prevent unexpected startup, including protective devices and energy dissipation. So the long and short of this is you must dissipate energy in a machine unless it is unsafe to do so, in which case you must have a secondary means of stopping, blocking, or holding a load in place. So this is law in the U.S. under ANSI, who have adopted this ISO standard. And then there's OSHA with the General Duties Clause. So basically how this works is OSHA can cite general duties and claim the workplace is unsafe and fine you. It's a very generic legal leverage that they have. If they come into a facility and feel that it is not compliant or safe, they have the right to make it correct, to write you a fine, and you have a number of days to remedy what they have found to be a deficiency. So despite all the legislation and standards we have in place, that General Duties Clause can override, and it is at the discretion of the authority having jurisdiction, in other words, the OSHA inspector. So how all of this works is, these organizations work together, and, some of my favorite comments in standards are, it is assumed that when present on a machine, a hazard will sooner or later lead to harm if no protective measure or measures have been implemented. And that is ANSI ISO 12100, which was adopted from the 13849 standard. And it's very clear that all of these standards basically point to a safe state is obtained on a machine by release of energy. So we want to work with industry, work with the markets, work with our customers, and help them achieve a safe state on machinery. Now, the final section is how we can help. Some of the things we can do, and some of the, and these, these aren't specific product things, but in general, there are products in the market to remove residual energy, and they're known as safety exhaust valves. I've kind of illustrated here how they work. A compressor provides pneumatic pressure through a filter regulator into a machine. And the safety exhaust valve, let me see if I have a laser pointer down here. I do. Okay, so this unit here, the safety exhaust valve, is wired to a safety circuit. So if you had a light curtain, you could use some kind of safe relay and PLC, or if you wanted to achieve a higher rating, you could use a safety rated logic controller. And this particular safety exhaust valve, if there is a fault or an e-stop, will open and exhaust out the machine. So that's one way to eliminate trapped energy. Another way we can help with machine safety is we have the ability to provide safe power. And a lot of plants have migrated away from hard wiring and field bus, and they're now using industrial Ethernet networks. And there's a lot of features and benefits to going to industrial Ethernet. One of them is a certain type of product that allows you to run safe auxiliary power into it. And you can see here, laser pointer again, using a safe power supply to machinery directives, we are able to connect safe power in. This is a valve driver powering a valve manifold, and we can actually daisy chain that safe power out and continue safe power through the plant. And what this will do is if someone breaches the light curtain, you're going to kill that safe auxiliary power all the way through the plant, so you'll lose the power on the valve manifold, but you'll still have logic or communication back to the PLC with Ethernet. So there's another way to enhance safety on machine. We have the ability today to zone a machine, and this is common in Europe, but not so common in the US. It's just starting to catch on. There is electrical zoning and pneumatic zoning. What I'm showing here today is pneumatic zoning. So we have taken a valve manifold, we have created pressure zone 1 and pressure zone 2. Let me get a laser pointer. So here's pressure zone 1 and pressure zone 2. And what we have done, and I know this looks complicated, we've run Ethernet down from a PLC to a master. We're powering this valve with an IO link connection, and we have zoning here. We've also connected safe power to this manifold, so if we have a light curtain breach, we will kill safe power, and we can connect that power to zone 1 or zone 2. This is handy if something is jammed in a machine and you need to go in and do some kind of maintenance. You have safety now. You have killed your pneumatic pressure, returned your valves to a home state, and you don't have supply pressure running through that manifold. Next, with industrial Ethernet, we have the ability to provide predictive data. And these are big industry buzzwords right now, but the long and short of it is by sending information back to the PLC, we can send information back that will help you better maintain your machine. So things like supply voltage warnings, short circuit protection, temperature warnings. We have thermal indicators in the products now that there's an overcurrent or a heat problem. We will let you know before that machine goes down. And if you need more detail, you can go inside the product into the electronics, into the parameter data, and you can export out or look at more detail on what's going on with that particular section of the machine. So that predictive data can be gathered and utilized or used as needed, and it is very, very handy to eliminate and prevent downtime. So on a machine, risk assessment should be conducted. And if you want to make a machine safer, you've got to identify the hazards. Risk assessments, step one, always design out the risk. But if you do a risk assessment and you cannot design out the risk, this is where we can come in and help you take technical measures to design out the risk, which means basically now you're into installing safety stuff and safety circuits. You want to find ways to protect from these hazards. It's not always feasible to go throw a guard up around a machine. Sometimes there isn't room. So you've got to get into interlocks and machine guards and light curtains, and always eliminating any trapped air. I see tons of machines every day in plants that store or hold pneumatic energy, and it's not for the purposes of holding a load in place. It's just simply old machine design. So it doesn't matter what you do. If you're an OEM, original equipment manufacturer or machine builder, if you're MRO and you're doing maintenance and repair in the field, or systems integrator or general industrial facility person, you have options. So the first thing is you can always call in OSHA. They will come in and help you. They will determine where your areas of deficiency are, and they will work with you to remedy those areas, and they give you a period of time, and they will work alongside you to help you. You can go out and have a risk assessment done. This risk assessment must be done by somebody other than the machine designer, so you can go to a third party and pay for that service, or you can use an engineer on staff, provided they have not built the machine. And of course, all of this should be documented. These European standards require risk assessment. If you're shipping machinery into Europe, you absolutely must do a risk assessment. But in general, it is good practice to have this. It covers you from a liability perspective. If there is somebody injured on a machine, you've done due diligence, you've done a risk assessment, you've documented the components you've used well-tried and trusted components, etc. Another option is obviously to discuss the solutions with somebody you trust, a trusted advisor, somebody who understands machine safety and has the people and the products to help you resolve challenges. So I highly recommend our G group for that role. And if you would like to contact them about any application-specific questions, Pete Wheeler is the contact, and I have all of his information here, even his cell phone and his email address. So now, I've covered a lot very quickly. I'm going to open the floor to any questions you may have, and I will try to answer them. If you would like the content from this presentation, please contact Pete. He would be happy to provide this to you. Any questions?
Okay, all right. If there are no questions, Linda, we certainly appreciate your time today. It's always nice to have the experts in the industry come on and give us their feedback of kind of where things are heading. I know a lot of times we see what happens over in Europe quickly comes over to the United States. So a lot of things that are law over in Europe, we can see those things happening here probably pretty quickly. I know Linda mentioned several times about risk assessments. That is a service that we absolutely can provide to you from the RG group. So if you are building machinery and you need to have a risk assessment done or like one done, please feel free to reach out to me. I'll be happy to coordinate that with you. But certainly going into the future, if you have any specific questions on any safety applications of your pneumatic equipment, please again feel free to reach out to me. My contact information is on here, and I'll be glad to help. And for those on the call, this recording will be going out in the coming days. So if you'd like to review any portion of this, a link will be sent out in the next few days, and you'll be able to rewatch that, review over any of the information that you did here, and certainly, again, the information for Linda's contact as well as my information will be on there, and we are more than happy to help you. So again, thank you everyone for your time. Appreciate you attending volume number 2 of our Did You Know education campaign, and we look forward to working with you in the future. Thank you.
And Pete, thank you for the opportunity to speak to your market today.
Thank you, Linda. Appreciate it. Well done. Thank you.
Thank you, Linda. Thank you, Pete.
Thanks.